Hi, I'm Roan Haynes, and today I'll be investigating the question, how do kaleidoscopes work in regards to physics?
Turn down for what?
Kaleidoscopes are a children's toy that create repeating patterns, sometimes simple and sometimes complex. The beautiful and fascinating images are created with light and mirrors. The history of the kaleidoscope started back in 1816, created by a Scottish physicist, Sir David Brewster. The device grew popularity quickly, and supply could not keep up with demand. The actual word kaleidoscope can be broken down into the Greek root kalos for beautiful, Indo-European root eidos for form, and Greek root scope to see. A kaleidoscope is more easily comprehensible when thought of as three parts of a whole, which I will walk through with the model that I created. The first piece is the main tube responsible for reflection. To function properly, all kaleidoscopes require some sort of reflective material, usually in the form of mirrors. For my homemade example, I use shiny plastic. Other reflective materials include aluminum foil, tin, and blown glass. Commonly, 3 mirrors are used to create a pattern based on repeating triangles all placed at 60 degrees. However, this can be manipulated depending on the desired pattern. I folded the plastic piece into an equilateral triangle and then placed it within this round hollow tube, which was a paper towel roll. The second component of a kaleidoscope is the object chamber, located on the far end of the entire device. The object chamber holds whatever objects are to be reflected, usually small pieces of colored glass or plastic. For my homemade example, I inserted small colored beads. The object chamber is closed off with glass or plastic, and in my homemade case, parchment paper, to allow light to filter through for reflection. Some kaleidoscopes feature a rotating object chamber, but if it does not include this feature, it must be rotated by hand when a light source is shining through the bottom. The final component of a kaleidoscope is the small viewing hole opposite the object chamber. In order to function properly, the user looks through the small viewing hole, allows the light source to come in through the object chamber, and rotates the kaleidoscope. The physics behind the kaleidoscope is fairly simple. First, the light is produced from any variety of source. The light then travels until it hits any medium or object, in this case, the mirrors inside the kaleidoscope tube. As the light is passing through the air, the particles are constantly bouncing off of one another until they reach the human eye through the small hole at the top of the kaleidoscope. As the kaleidoscope rotates, the reflections change depending on which objects are within closest proximity to the mirrors, creating the alluring visual that we see. This basic diagram shows the path of the light ray to the first mirror. Based on the law of reflection, we know that the angle of incidence equals the angle of reflection. Images are located where the outgoing light rays appear to intersect. In a kaleidoscope, mirrors are relatively flat, resulting in specular reflection. This means that the light is reflected at a definite angle. In the next diagram, the interaction of the mirrors can be seen. Light comes in from the bottom of the device to hit the first mirror, again, the image being located where the outgoing light rays appear to intersect. The image continues to reflect off of the second and then third mirrors, which also reflect back in the opposite directions, shown by the X figures that are really 2 arrows pointing inward at each other. Light reflects off of mirrors because the surface of the mirror turns back the electromagnetic wave. The colors we see depend on the wavelength of color that reflects from the object. Remember, these colors are on the visible light spectrum, falling between infrared and ultraviolet light, which range from 3.9 times 10 to the negative 7 meters to 1.0 times 10 to the negative 3 meters, and 430 hertz to 770 times 10 to the 12 hertz. Simultaneously, as color is reflected from an object, every other color on the visible light spectrum is being absorbed. So, for example, red parts of the image in the kaleidoscope are reflecting red and absorbing all other colors. Red has a relatively longer wavelength, lower frequency, and lower energy. The same goes for green and blue, the other primary colors. Other colors are a combination of mixed pigments, which subtract certain colors based on the frequencies of light that aren't absorbed by the pigment, such as yellow, magenta, and cyan. I think the most interesting part of kaleidoscopes is that the objects tumble in a random way, so the different types of patterns and mixing of colors are nearly never ending. Thank you for watching my Project Curiosity video answering the question, how does a kaleidoscope work?